Hello dear student, welcome to my YouTube channel. In this video, we will see anti-Markownikoff rule, or it is also called anti-Markownikoff orientation. So we will see with example and with its mechanism. So like the video and subscribe the channel for more updates. Now we will see anti-Markownikoff rule. So anti-Markownikoff rule, usually it has been asked to the student what is anti-Markownikoff rule. So they simply says it is opposite to an Markownikoff rule. Right? It is right, but one should know the statement what is an anti-Markownikoff rule. So for that purpose, we will see also in general reaction. See, the rule states that when asymmetric alkene is added to a protic acid, till there the statement is same as per an Markownikoff rule, but the statement it further modifies in presence of hydrogen peroxide, and that is why it is also said to be an peroxide effect, right? It is hydrogen peroxide that will react, and it is also said to be an peroxide effect. The acid positive part, hydrogen, becomes attached to a carbon which has least number of hydrogen. So very important to note over here, it is quite opposite to an Markownikoff rule that acid, the positive part of an hydrogen, become attached to a carbon which has least number of hydrogen, and the negative halide group becomes attached to a carbon which has more number of an hydrogen atoms. In case of an Markownikoff rule, we have seen that negative part get attached to a carbon which was having less number of hydrogen, and positive part it was getting attached to a carbon which is having more number of hydrogen. But in case of an anti-Markownikoff rule, the hydrogen will get attached to a carbon which is having least number, and halide will get attached to a carbon which is having more number of hydrogen. And here you can see that bromine has been attached to a terminal end, but not in the middle. So the yield, it is 94% yield. So it does not mean that it does not form another product, but the major product that we get, it is an anti-Markownikoff product. Say we will say it is an anti-Markownikoff product. Now further, and very important to note that it is also said to be an peroxide effect, that is in presence of an peroxide, HBr reaction will always yield anti-Markownikoff product. Anti-Markownikoff addition reaction is found to follow free radical mechanism. The peroxide compound involved helps in the generation of a free radical. See, in case of an halogenation of an alkenes, we have seen that homolysis takes place, and that homolysis causes the free radical formation. Same thing happens over here. This H2O2, that is hydrogen peroxide, it causes homolysis, and that homolysis continues further and it forms a free radical in the whole reaction, and that is why we get N-propyl bromide instead of an isopropyl bromide as a Markownikoff rule. But to understand this, why that H it get attached to an carbon which is having less number of hydrogen atom, and why the bromine get attached to an carbon which is having more number of hydrogen atoms. So understand this, one should understand the mechanism. Right? So it is having some logics, it is having some science behind it. Firstly, that is generation of free radicals through an homolytic cleavage. Once by an homolytic cleavage, the free radicals are being generated of an peroxide compound, then they will attack generated free radicals. They will attack a hydrogen halide to form a halide radical through an homolysis. Attack of generated halide radical on alkene molecule to form an alkyl radical through homolysis. The attack of generated alkyl radical on hydrogen halide to form alkyl halide through homolytic cleavage of an hydrogen halide bond. So we will see one by one. See, the first step is that generation of free radical through homolytic cleavage of peroxide compound. So it is peroxide compound. Here instead of hydrogen I have taken R, so it is a peroxide compound, and that peroxide compound, it will be equally distributed, means the bond breaking, it will be equal, it will be an homolytic cleavage, and so that is why the free radicals, they are being generated. So once the free radicals are generated, the second step is that attack of generated free radical on hydrogen halide to form halide radical through homolysis. Once this free radical of an peroxide they are been formed, they will cleave the halide in homolytic way only. As such, halide compounds they are not homolytically cleaved; they are cleaved heterolytically. But due to presence of an one of an free radical from this peroxide, it causes halide to cleave it homolytically. And once homolytically cleaved halide, it will give an free radical of an halide. And this free radical of an halide, now it will cleave the alkene. Alkene, it is our substrate. So that alkene, it will break the pi bond between the alkene carbon it will break, and it will the CH2 it will combine with the Br radical, and we will get the middle carbon, which is now an free radical carbon. And in the next step again HBr it will be added, and HBr it will be again homolytically cleaved, and homolytically cleaved HBr hydrogen will get attached with an carbon, right? Hydrogen will get attached with an carbon. But now what is the reason that why the carbon it is why the bromine it get attached to only CH2, why not to this middle CH, and why the hydrogen it get attached to only this CH? As it is next step it will so whatever will be the vacant it will get attached to the carbon. But why the bromine get attached to only CH2? It is having some uh, logic behind it. So logic behind it is very simple, that free radicals generated have the stability in order that tertiary free radicals are more stable than secondary than primary. Say suppose instead of this step I will write over here CH3 and CH. So instead of this Br attaching to this CH2, if I attach the Br free radical towards the carbon number 2, and CH2 it will remain as it is, that radical, and Br I will attach over here. See, the difference is that the free radical generated of an alkyl halide, so that alkyl halide free radical generated, this carbon it is secondary carbon because it is having attachment of an 2 carbons on the adjacent side, but this carbon it is only an primary carbon. And if we look the stability of an primary carbon and secondary carbon, so secondary carbon it is more stable than primary. So that is why this it will be in a minor form. We will get this product but in very less quantity, and majorly we will get of an secondary free radical, right? We will get of an secondary free radical major product, and that is why that bromine get attached to this terminal CH2 but not to the middle CH2, as it is unstable molecule or unstable radical which has been generated, which is primary, and this one it is a secondary generated free radical. So that was the difference between Markownikoff and anti-Markownikoff rule. So that it is exactly opposite, but it is due to an hydrogen peroxide. Hope so you understood the concept. If you are having any doubt, comment me in the comments box. I will surely answer it. Thank you for watching the video.